Hello, my dear students. Welcome to the final year class. In this session, you are going to study the conditional and selected signal assignment statement under the Unit 2. So, let us remind what is your Unit 2. Unit 2 is data flow modeling. Okay. So, in this session, you are going to study the conditional signal assignment statement, selection signal assignment statement, its general format, and the working of the conditional and the selection signal assignment statement with examples. Okay, let us move to the conditional signal assignment statement. Okay, so all of you, we studied the signal assignment statement, which is called the signal assignment statement. This is the symbol of the signal assignment statement. Okay, we studied the signal assignment statement. What is the signal assignment statement? So, signal assignment statement is nothing but some equation is there. It is evaluating and giving values to that signal. That is nothing but what our signal assignment statement. What do you mean by the conditional signal assignment statement? Depends on the condition, the signal assignment statement is going to execute it. That is called what your conditional signal assignment statement. Okay, assignment statement what you studied in the mathematics equal to is called the assignment statement. Okay, and this is called what your signal assignment statement. What is the conditional signal assignment statement? Depends on the condition, this assignment statement is going to execute it and that value is assigned to the signal. So that is why it is called a conditional signal assignment statement. Okay, so let us remind once again this one. The conditional signal assignment statement selects different values for the target signal based on the specified possibly different conditions. Okay, and you remember that this conditional statement is similar to the if statement what we studied the if statement under the sequential statement. Okay, so only the thing is somewhat the syntax is different but the working is same as if statement. Okay, those if you have not read or if you have not remember the working of the if statement, already you have the video. Once again you go and once again you go through the working of the if statement. Okay, now let us study the target. Let us study the syntax of the conditional signal assignment statement. Okay, so it's begin with the target signal. Target signal is nothing but the output signal. Okay, and next the signal assignment statement, and next waveform element, when, condition, and the else. Here you see here any number of waveform elements you can write. Okay, and here when and else are what? They are the keywords, and this is what your condition. In this way you can write any number of waveform elements here, but the final is the one waveform element when condition. Okay, and what are the points you have to remember? There is no semicolon here. Okay, remember that there is no semicolon for each and every waveform element in the conditional signal assignment statement. Only for the final statement you are going to get the semicolon. Okay, and next comes what do you mean by the waveform element? Waveform element that also we studied in the creating signals. Okay, so those who are unable to remember what are the waveform elements, just go and see the creating signals that there I have explained what are the waveform elements. Okay, now let us see the working of this working of this conditional signal statement. Okay, I already told it is just like an if statement. Okay, So here what happens, some events occurs on the waveform elements are the condition. Here what happens, the control is going to check 111 condition. When the condition is true, that value is assigned to the target signal. Okay. If for example, you think that if the second condition is true, then what happens? It is going to assign this value. So here you see first it is going to check the first waveform element with its condition. Here you have written else. That means if this condition is false, means it is going to check the next condition. Once again, this is false means the next one. And this is false means the next one. In this way, it checks all the condition. Okay, if any one condition is true, then that value is assigned to the target signal. And it is not going to check any others according to the same if statement. But here what happens? So one final is there. All the conditions are false. Then what happens? So here this is the going to execute here. Okay, next let us see the example. Okay, here what is the example means, you see here IN0 is a one waveform element. So this is full is nothing but it is one waveform element. IN0 after 10 nanoseconds is one waveform element. And what is the condition here? When S0 is equal to 0 and S1 is equal to 0. Is the condition. So here you see these else and when and the after all are called what? The keywords. So here I tried to put all the keywords in the bold letters. Okay, and these are the conditions. Okay, here you see the working means here if the any events, this is called Z is called what? Your target signal. Yeah, and this is the signal assignment statement. This is what your example for the conditional signal assignment statement. That means depends on these conditions, these are going to execute it and gives the value to this target signal. Some event occurs on these signals, that is IN0 to IN3, and in the same way for the conditions. Okay, and this starts the control is coming from one by one line. So first what happens, it checks the is the condition is S0 is equal to 0 and S1 is equal to 0. If this condition is false, because of this else what happens, it is going to execute the next statement, that is IN1. And once again, if this condition is also false, then what happens? It checks the next statement. If all these three are false, then it is going to execute. That means it gives the value for the target signal is IN3 after 10 nanoseconds. Okay, after 10 nanoseconds, the IN3 value is given here. But what happens here? I am thinking that the second condition is true. That means when S0 is equal to 1 and S1 is equal to 0, if this condition is true, then what happens? IN1 is assigned to target signal, that too after 10 nanoseconds. Okay. And next one is the same program. If you want, you can write using the process statement. Okay, that I have already told. What is that? Conditional statement is nothing but it is same as the if statement. Okay, so here I have written the program, that is in the process you can write using the else if statement. Okay, so this is about what your conditional statement. And using the conditional statement, we can write the encoder program also. Here this is a 4 into 2 encoder program. Okay. But my dear students, in this program, something is wrong. You have to find out that what is the mistake in the program, and in the same way you have to say that is this program is correct and is it going to execute it or not. I leave this program for you only. Okay, just you try to analyze this program. Is this program is going to execute it, and what are the errors in the program? Okay, and I think all of you know the encoder and working of the encoder. Okay, now let us move to the selected signal assignment statement. Okay, what is the meaning of selected signal assignment statement? Once again, what happens here? Signal assignment statement is the same. Okay, it is going to select the signal assignment statement. Okay, so what is the selected signal assignment statement? The selected signal assignment statement selects different values for a target signal based on the value of selected expression. Just it is like a case statement. Okay, I think we have studied the case statement under the sequential statements only. Okay, just you go through it, the case statement, the same working is there. Okay, and here it is called what your selected signal assignment statement. Okay, so just here we have comparing the case statement with the selected signal assignment so that it is very easy to understand the concept. Okay, now students move to the syntax of the selected signal assignment statement. Okay, this is the syntax. Remember students, all of you should be perfect with all the syntax. In the examination, they may ask only the syntax or they may ask the syntax with the explanation and with the examples. Okay, this conditional and the selected signal assignment statement syntax can be asked for the 2 marks also. Okay, so here selected signal assignment statement syntax begins with the keyword with expression and the select keyword. With expression and the select. Afterwards, what happens? The target signal is there, and this is what our signal assignment statement is there. Waveform element when choices and comma is there. Remember that here waveform element when choices and the comma. Waveform element when choices and the comma. And finally is waveform element when and the choices, and here it is a semicolon is there. Okay, and this is what the general syntax of your selected signal assignment statement. Okay, with expression and the select target signal wave. What is this signal assignment statement? Waveform element when choices and comma is there. Comma is there. That means any number of waveform elements you can write. And finally, final is nothing but here it is the semicolon is there. Okay, let us revise the selected signal assignment statement. What is the selected signal assignment statement? The selected signal assignment statement selects different values for the target signal. It is going to select the different values for the target signals based on the value of selected expression. Just it is like in a case statement. Remember that here what are the bold letters I have written? These are called the keywords. Okay. Now working. Okay, I will explain the working with the example. Okay, here the example is there. So here one op is a one type of the variable and it is how many of their add, subtract, multiplication and division. And it is the O op underscore code is another one signal I have taken. It is of the type OP. Okay, type is a one. Just you remember what is the type and where we have used. This also I have explained in the previous videos. Okay. And here I start the program with O with is a keyword. OP or underscore code is a your expression and the select. And Z is the target signal assignment statement. So what I am writing here, A plus B after add underscore propagation underscore delay. This is what your waveform element. When and here the choice is there. What is our choice? Add. So what I am telling in this expression, this is the waveform element. Okay, A plus B after add underscore propagation delay. Actually, instead of this, you can directly take the 10 nanoseconds, 15 nanoseconds like that. Just I want to change. I want to change, or I want to show that in some books it is taken like this also, and you can also use this. I want to show this, so I have written this example here. So what is my aim here in this in this statement is when your opcode is equal to add. That means when you are added, when you are selected, opcode is equal to add, then what happens? It is going to execute a plus b, and it's after add propagation delay, it gives value to the z. Okay, in the same way I have written for the a minus b after sub underscore propagation delay when sub. Similarly for the multiplication and the division. Okay, don't confuse. This is very simple. Okay, just this is a addition when I have selected add, and this is subtraction when I have selected sub, and this is going to multiplication, and only here we are understanding that after add underscore propagation delay. This is the one another variable we have taken. Okay, so how this is going to work here? So you think that you have selected the add here. That means your opcode is add. And here also you have, what happens? We have selected means this is also add. Then what happens? This is a selected signal assignment statement. Okay. So it directly selects the add, and it find the value of addition of a plus b and gives the value to the z. Okay, so here you can ask the question that it is a first, then it selects. But then what happens means you think that I have selected the MUL as your opcode. That means now our expression is the multiplication. Directly the control goes to the MUL, and it is going to execute the multiplication, and it gives the value to the Z. Okay, so this is what the working of a selected signal assignment statement. Okay, remember that selected signal assignment statement is not executed line by line. Okay, it is executed by selecting the expressions directly. Okay, in the same way division means it is going to select the division. Okay, but what we have to do means after writing this, okay, you have written this, no? For each and everything, we have to write the one process statement for this one. How case opcode is when add is equal to za plus b after this one. That means for each and every waveform element, you are going to write the process statement. Okay, and this is what the same our behavioral, how we are writing now using the case statement we have to write. Okay, finally end process. Okay, and here I have written that is the one example with lot of complicated variables. Okay, so I want to tell you one simple example to understand the decoder using the selection signal assignment statement. Okay, so I think you have understood what is the selection or the selected signal assignment statements. That means depends on the expression, it is going to execute the single statement. It is not going to check all the conditions. Okay, so let us see this simple example for the decoder. Here you are seeing the block diagram of the decoder. Okay, here what happens, input is there, how it is a 2 to 4 decoder. Okay, so just please go through once again what is the 2 to 4 decoder. Here just I am explaining you that 2 to 4 decoder is nothing but it has the 2 inputs and the 4 outputs. Okay, what are the 2 inputs I have given? That is a standard inputs, that is 0, 0, 0, 1, 1, 0 and 1, 1. And what are the outputs? 4 outputs you are getting. When your inputs are 0, 0, you are going to get the 1 output. When your input is 1, you are going to get the 2 output. When it is 2, you are going to get the 3. When it is 3, you are going to get the 4. That is what your 2 to 4 decoder. Okay, and here you see here, this is the block diagram what I have sent. This line shows it has more than one input. This line shows the more than one output. Okay, so this is the block diagram for the decoder, and this is the truth table for the decoder. Now let us write a one VHDL program, that too using selected signal assignment statement. Okay, so all of you know first what we have to write. These 4 lines we have to write, and next in this let us write the entity part. So here I will explain you how to write the entity part also. All of you are, I think all of you are very perfect with the entity part. Okay, so first this is begin with the keyword entity. Name of the entity what I have taken, decoder 1, and the is. So here nothing is there, no semicolon, no comma, no full stop is there. And next I have to write the port. In the port, what is the entity is nothing but what it is, the how many inputs and how many outputs we are going to write here. So here port in standard logic, and I have taken the which data type here, it is vector, because it has the two inputs. Two inputs. It has the two inputs. Okay, and why, how many outputs are there? There are the 4 outputs are there. Okay, that is 3 down to 0 and it is 1 down to 0. Remember that here whenever you are writing the down means it should be the big number and this should be the lowest number, because 1 down to 0, that means first one is I of 0. So what is this? Your first input is I of 0. Second one is your I of 1. In the same way, 4 outputs are there, that is y of 0, y of 1, y of 2 and y of 3. And so here 4 outputs I have written, and this is what your 2 inputs, and this is end decoder 1. Now let us move to the architecture part. So how you have to write architecture? Behavioral of decoder 1 is, and here begin, and what I have to do, I have to select the selected signal assignment statement. So it begins with the keyword with, and the expression is I and the select. Okay, and here the target signal is I is equal to 0 0 1 when 0 0, and this is the thing. Okay, that means the same thing we have to write. Output we are going to get when it is 0 0 and 1 0 0 when it is 1 and others. So in the selected signal, one important thing is here all the conditions are present. So if these conditions are not satisfied means what we are writing others. That means for any other condition what it should do, it is going to display 0 0 0. Okay. So you see here I have selected 1 1 is there, 1 0 is there, 0 1 is 0 0. Other than this, if I have selected that is 0 0 0 1, then what should be the answer? The answer should be the 0 0. That means one important thing about the selected signal assignment statement is, in this selected signal assignment statement all the conditions are going to executed. Okay. So whenever we are having lot of conditions and next to some other conditions also there, that type of the applications we are using the decoder circuit. Okay, let us hope that all of you understood the decoder using the selected signal assignment statement. Okay. Now another one important thing about the same is the unaffected value. What is this unaffected value means here? Actually, the unaffected is keyword. Okay, all of you know unaffected is a keyword. Why we are using here? It's what is unaffected. Usually in the English also, nothing is affected to, that is nothing but what, unaffected. Okay. So here also it is the same meaning. So, but it is important. In our digital circuits, it is very important. Okay, I will explain you how it is very important. Unaffected is a keyword used to retain its previous value if it satisfies certain conditions. Okay, after satisfying some condition, it remains in the previous value. Okay, that type of the condition, that type of the circuits, we are using the unaffected. So from where, in which circuits that type of the working is there, if you have remembered, usually whenever we are explaining the some flip-flop circuits, we are saying that if some condition is there, for example, if it S is equal to 0, R is equal to 0, it is a retains in the previous value. Okay, in that type of the applications, if you are writing the programs, then it is very useful. Okay, so here I have written the one example also. You remember that the JK flip-flop is there. So in the JK flip-flop, what happens if both the inputs are 0? It can be written by using the, so in both the inputs are 0, the output retains its previous value. Okay, how you can write this? Like this: Q is equal to unaffected when J is equal to 0 and K is equal to 0. In JK flip-flop, if both the inputs are 0, what should be the targeted signal? It is unaffected, whatever may be the previous value. It may be the 1 or it may be the 0. In this type of the situation, you are going to use the unaffected keyword. Okay, you see here another example is there. So just I have written once again using the keyword type, and the state type is here. How many I have taken? You see just here: receive, hold, waits, apply and reset. It is of the type. And once again, I have another one taken as a next underscore state. It is of the state type. So here, how you are going to use the unaffected with select signal, with next state and the select. And here, this is what your target signal. This is the signal assignment statement. B0001 when apply. And I have taken as apply, and when I have selected waits, you are going to get this output. When it is reset, you are going to get this output. Unaffected when others. That means here I have taken how many conditions are there? 1, 2, 3, 4, 5 conditions are there. You can take any number of conditions. So here, for example, I have taken 5. But what happens if I select waits? Next state is also wait. Directly it selects waits. Your target signal is 0010. Okay, but what happens? I have selected the reset, hold, or the receive. Then what happens if I have selected reset, hold, or the receive? Sorry, reset, no. Reset means it is going to select. If I have selected the hold and the receive, what happens? Nothing is there. It is going to execute this condition unaffected when others. This is called the others. That means you have not written any conditions for this one. But I have selected the hold and receive because it is there in the choices. Okay. But here what happens? Unaffected means it remains in the previous value. Whatever your target value is known to, that is present. That is nothing but what? The unaffected. Okay. So here another one is there, that is mark flag. Okay. Else unaffected. So if you have selected any other things, then also it is unaffected. Like that, the continuation is there for that one. Okay. Please go through once again the video. What we studied in this video, let us summarize once again. So first we have selected the conditional signal assignment statement. Afterwards, its general format you studied, and its example and its working. Okay, very, very important. These are all the 4 things we studied for the selected signal assignment statement, and finally we studied the one unaffected value. Okay, please dear students, go through once again that video. Try to understand the concepts. If you have any doubts, put the doubts in the comment box. Okay, thank you.